Hello, good day. You're welcome back. This one says, write the complex numbers in polar forms with argument between 0 and 2 pi. Of course, 2 pi means 360 degrees. All right. So these are the complex number. This complex number 3 plus 4i and complex number 8i. So we are asked to write these two complex numbers in their polar form. All right. So solution first, I want you to know the polar form of a complex number z is equal to r into cos theta plus I sine theta. Now, this is nothing but the polar form of a complex number. So it means that this complex number given to me, now of course, I want you to understand that this complex number now is nothing but in their standard form or in their basic form, in the form of a plus bi. And now we are asked to transform them in polar form, which is this. So if I can get the argument of this complex number and again get the modulus of this complex number, I will simply substitute them inside this general formula, and that's my polar form. All right. So what I need to do to these two complex numbers now is first get their modulus, which is nothing but r, and again get their argument, which is nothing but this theta you see here. So once I've gotten those things, I will quickly impute them here, and that's it for my polar form of the complex number. All right. So note that the angle is the argument, the r here is the modulus. Now this argument you see here, argument simply means the angle, which is theta. Okay, so for me now to get the modulus of this complex number, I've already taught you guys how to get modulus of a complex number. Modulus of a complex number simply means the magnitude of that complex number. All right, and the formula for getting modulus of a complex number is r equal to square root of a squared plus b squared. So that's the formula for getting modulus of a complex number, and this is the formula for polar form of a complex number. So this complex number now, let's get the modulus. Therefore, the r for this, let's start for I. R is nothing but square root of a is 3 squared plus 4, nothing but 5. All right. So 5 is the modulus of this complex number. What about the argument of this complex number? Now, for us to get argument of a complex number, it is almost impossible to get it without first drawing the, not that almost impossible anyway, but for us to get argument of a complex number very clearly, we have to draw the Argand diagram of that complex number. So drawing the Argand diagram, this is the vertical, this is the horizontal. All right, and the horizontal axis is nothing but the real axis, the vertical axis is the imaginary axis. Now this 3 you see here is the real part and it is positive, so we're going to place it somewhere here, and this 4i is the imaginary part and it is positive, so we'll place it somewhere here, such that this is going to be the diagonal and here is nothing, is going to be the argument. Now we're going to maybe enclose this such that here again is also 4. Now, this angle theta, this theta you see here is nothing but the argument we are looking for. And we can use this angle formula that says that tan theta is nothing but opposite over adjacent. And of course, this is the opposite, this is the adjacent. So tan theta is nothing but 4 over 3. Therefore, theta is nothing but tan inverse of 4 over 3. And tan inverse of 4 over 3 is nothing but 53.130 degrees. So 53.130 degrees is nothing but the argument of this complex number. Now, don't forget that this is the formula for putting a complex number in polar form. So now, for this particular complex number, we have gotten the modulus to be 5, and we have gotten the argument by reason of this now to be 53.130 degrees. So we can plug in this 5, now we put it here, then put this 53.130 inside here and here, and that's it for, that is the modulus, that is the polar form of this complex number. Okay, let's just write it over here. Therefore, number 3 plus 4i is equal to 5 into cos 53.130 plus I sine 53.130 degrees. All right. So that's it. So this complex number in the basic form, this is its polar form. It's as simple as that. Okay, let me quickly wipe off this part and solve for the second one. Now, for the second one, don't forget this is the formula for getting the modulus, and this is the formula for the polar form. Now, for this complex number now, you find out that this is just 8i. This complex number has no real part, or rather, I can still express this, you see, as 0 plus 8i, because the real part is 0. It does not exist. The only thing that is here is just the imaginary part. Now, if this is same thing as this, we can now get the modulus. Therefore, the modulus of this complex number is just that r is equal to square root of 0 squared plus 8 squared, which is nothing but 8. All right, so the modulus of this complex number is 8. What about the argument? Now, to find argument of a complex number, let us draw the Argand diagram. Now, drawing the Argand diagram, you find that this is the horizontal is the x-axis, or yeah, the horizontal is the x-axis, which is the real part, and the vertical is the imaginary part. Now, the vertical being the imaginary part, from this point, from this point here, which is the origin, upwards is positive imaginary part, and here down is negative imaginary part. But if you watch carefully on this complex number given to us here, this 8i, you find that 8i is nothing but a positive imaginary part. So if it is positive imaginary part, we're going to take it from here upwards. Now, but lest I forget, argument of a complex number, that is that theta, argument of a complex number is the angle taken from the positive x-axis to the diagonal. So the angle has to be taken from the positive x-axis. So this is the x-axis, and the whole of this actually is the x-axis, but from here towards this part is the positive x-axis. From here towards this part is the negative x-axis. So the definition says that it is the angle taken from the positive x-axis anti-clockwise to the diagonal. So now this is more like this is the diagonal, because this is where that 8 falls. All right, that 8, even though it is 8i, so this is the 8 here. So we don't need to put I, because the axis depicts that I is the one that will occupy the whole of the axis. All right, so we take it anti-clockwise until it touches the diagonal. So this is going to be our theta, and of course you find that if you watch carefully, now this is nothing but 90 degrees. Therefore, from here now we don't need to solve further. Our theta is equal to 90 degrees. I hope you understand this better. Let me just say, we can rewind the video and get the and listen to it over and over again. All right, so theta is equal to 90 degrees by reason of our diagrammatic expression here, and our modulus r is nothing but 8. So having gotten theta and getting r, we can now substitute this and this into this formula and get the polar form of this complex number. Therefore, 8i is equal to 8 into cos 90 plus I sine 90, of course, degrees. All right. And now don't forget that you can still put the angles. You can convert the angles from degrees to radians. It is still very, very possible. All right. So this is it for this particular question. See you in the next part of this video.